Many of you may be asking yourselves, since we're talking about equilibrium, and in equilibrium the reactants become the products and the products become the reactants, then does the direction that I actually write the equation in really matter? In many circumstances, you're right, it doesn't. You could actually put the products first and it would still be the same equilibrium. Unfortunately, the K value is calculated in such a way that it's only the products divided by the reactants. So once you have that equation written down on paper, that Kc value is rather locked. And it's not going to be the same for the reverse reaction. So yes and no, it does matter on paper, but it doesn't necessarily matter when you're looking at it in the beaker. So let's say, for example, that you are going to do another sort of problem, and it might be more convenient for you to be thinking about the reverse reaction of an equation that we have been studying. And you have the wrong K value, and all of a sudden you need it for the reverse reaction. And you're thinking, oh my goodness, now that's going to be a whole bunch of work. I'm going to have to do a whole bunch of experiments to try and figure out what this new and adjusted K value is. But there's actually a very easy mathematical way of figuring this out. Let's take a look. So far, we've been studying this little equation, A plus B makes C plus D. And in order to calculate the Kc value, we would take the product concentration, C and D, divided by the reactant concentration, A and B. Well, if we were considering the reverse reaction, C plus D makes A plus B, then to calculate its Kc value, it would be the concentration of its products, A and B, divided by its reactants, C and D. In other words, the inverse of our previous calculation. We call this value Kc prime. The easiest way of calculating it is to take your original K value and raise it to the -1 power, essentially taking its reciprocal. And you'll have your new and adjusted K value. It's super duper fast. However, there are some circumstances where it's not going to be just as easy as wanting to flip the equation around. Sometimes we may need to manipulate the coefficients in front of that equation as well. So for example, maybe I wanted to go through and divide all of my coefficients by a factor of 2. Well, remember that the coefficients become the powers in that Kc value. So all of my powers would be divided by 2. I can pull that common factor out, and essentially my whole Kc value then becomes raised to that 1/2 power. The bottom line here is that whatever you do to your coefficients, it's going to be consistent throughout your entire equation. You can then raise Kc to that power. So if I wanted to multiply through by a factor of 3, all of my coefficients, then Kc gets raised to the 3rd power. If I wanted to divide by a factor of 5, then Kc gets raised to the 1/5 power. If I wanted to take the reverse reaction and multiply all my coefficients by 2, I would raise Kc to the -2nd. Let's take a look at another example. This is going to be example number 4 from your in-class problem packet. In-class problem packet number 4 gives you the reverse reaction of what we've been looking at in example number 2. And it simply asks you to calculate Kc, the equilibrium constant, by 2 different methods. The equilibrium concentrations are still going to be valid here. So respectively, the PCl5 and Cl2 are still going to be at 0.60 molar, and the PCl5 will be at 0.4 molar. So let's take a look at how we could calculate this. We can always take the traditional approach. So we could just make a Kc calculation for this and plug and chug in our calculations, our numbers, and figure out what it actually all equals. In this case, it would be the concentration of PCl5 divided by the concentration of PCl3 times Cl2. Plug and chug your values into that, and it actually comes out automatically with the value of 1.11. This theoretically would be our Kc prime, considering that this is the reverse reaction of problem number 2. Well, there's an even easier way. We had already calculated the equilibrium constant for problem number 2. So that equation, again, it's the reverse equation, had the Kc value of 0.90. So to try and get the Kc value for the reverse reaction, PCl3 plus Cl2 makes PCl5, I could simply take the Kc value and find Kc prime, taking 0.90 raised to the -1 power. And what do you know? We come out with the exact same value of 1.11. So bottom line, whatever you do to your equation, you have to raise Kc to that value to adjust the K value.